Welcome to Ask and Learn.
Here in this question, one equation is given and the product is a complex and it can have cis and trans isomerism. And the question is, what would be the expected ratio of cis to trans isomers in the product? Now, for this, we are supposed to know the structure or geometry of the molecule first, and then only we can decide what will be the expected ratio. So here it is, the cobalt is the central metal atom and octahedral complex is formed. So out of this, 4 are in one plane, one is above the plane and other should be below the plane. So if it is trans isomer, chlorine should be farthest from each other and remaining positions are occupied by ammonia. So ammonia is forming the coordinate bond with the central metal atom in the remaining position of the octahedral site. So this should be trans isomer, and if it is a complex, it should be inside the bracket, and outside the bracket only one positive charge is present. And if it is cis isomer, then the same cobalt is at the center and 4 bonds are in the same plane and one is above the plane and other should be below the plane. And here chlorine and chlorine adjacent to each other, that means the cis isomer, and the remaining positions you can fill with ammonia. That means the ammonia is forming the coordinate bond with the central metal atom. 4 ammonia molecules in the product. So this is again inside the bracket and outside the bracket charge will remain same. So this should be trans isomer, trans, and this should be cis isomer. Now the question is, what would be the expected ratio of cis and trans isomers in the product? Without experiment, what I feel that it is very difficult to decide the ratio of cis and trans isomers in the product. Because during the preparation, many factors like temperature, nature of the solvent, pH of the solution, etc. are working simultaneously. So which product will be more or less, it exact ratio we cannot decide without the experiment. But certainly we can say one thing, that proportion of trans product, this one, should be more than the cis product. The reason is 2 negative chloride minus ions ligands are opposite to one another in case of trans. They are opposite to one another, and so the isomers has the less repulsion and more stability. Because of that only we can expect that trans isomer should be more in the product as compared to cis. Here what happens in cis, 2 negative chloride minus ions are adjacent to each other. This one, they are adjacent to each other, so repulsion will be more and stability will be less in this case. So cis isomer is less stable. And it is more stable. So by this we can say that in the product the ratio or proportion of trans isomer will be more as compared to cis, but how much it will be more, it will again depend upon the reaction conditions.